All right, question 6. Once again, if you're needing to use the video to review, that's perfectly okay, but make sure that you're able to go back and do these problems kind of in isolation as well. You want to be fully ready for tomorrow's test. And if you need more examples, please go back to the book. All right, so we're going to sketch f of x, then factor f of x first if necessary, because that's going to help us to graph it. Lastly, label the roots and make sure we show in our work. So a. Now, as I look at a, I'm realizing that this is a third degree, and that my a value here is a positive 1. So I know that it's a third degree, meaning it's an odd degree function, and it's positive a value. So it's going to be starting from down here at negative infinity, and it's going to end heading up to positive infinity. Just some stuff I'm kind of keeping in my head as we go forward. My first factor, since this one is, my first root, since this one is factored for us, I get 0, 2, and negative 4. 0, 2, and 1, 2, 3, negative 4. All right, and now they're all single roots, and this is going to be as neat as and kind of in-depth as your graph really needs to be at this point. So starting from down below, heading up, it's got to make a turn to get back through my root right here. Coming down, can turn to head back up, and heads going towards positive infinity. My roots, to make sure I label them, are negative 4, 0, 0, 0, and 2, 0. Here's b. So we've got this function here, and I'm looking at it, and hey, I can factor out an x from each of these. So I have f of x equals x times x squared plus 3x minus 4. All right, and looking at that, I can factor this second piece. This is going to be a factorable quadratic. So I have x times x plus 1 and x minus 4. And again, I know my roots, and this is equal to f of x. My first root is 0, my second one is negative 1, and my last one is positive 4. Looking back at what we have at the beginning, this is a third degree, so odd, meaning the two end behaviors, they're going opposite directions. And my a value out here in front is positive. So it's going to start at negative infinity and end at positive infinity and go through my 3 roots. And they're all single roots, so nothing funky going on here. Just head on up. It's got to make a turn to come back through. And lastly, come on through and heads towards positive infinity. All right, number B, or C, I guess it is. See, this one is already in factored form for us as well, and that's great. And I'm looking at it, so I'm going to have x squared here, and I have x squared over here, and that means this is a 4th degree polynomial here. And so that's even, meaning the two end behaviors go the same direction. My a value is positive, and so this time I know that it's starting at positive infinity and it ends at positive infinity. Now, my first roots, I've got a root of 2 and 2, it's a double root, and a root of negative 3 and negative 3, it's a double root there as well. So positive 2 and negative 3. And at those double roots, that's where it's going to turn around. It does not cross the axis, just barely comes down and touches it, heads back up. Now it's going to have to head back down again and just barely touch and bounce back off and head back up towards positive infinity. All right, and you could go through and figure out exactly where your y intercept is. You would just plug in an x value of 0, and you could get that really exact. But really, what we're looking for here is where are your roots at, and can you get the general shape of the graph? So that's a root of negative 3, 0, and of 2, 0. Last one. And D, I'm looking at it, and depending on how you factor, this may be a little bit easier or harder, and you can factor by grouping, by factoring out an x squared on the first two and a negative 1 from the last two. Personally, I've always been a big fan of the box method, so we've got x cubed, negative 2x. Let me make this box a little bit bigger for us. So we've got x cubed minus 2x squared minus x and plus 2. And so looking here, and I've got a negative 2 that I can factor out of both of these. Now what times negative 2 gives me positive 2? Well, that's going to be negative 1. What times negative 1 gives me negative x? Well, that's x. And what times x gives me x cubed? That's x squared. So my first factors, I'm going to actually continue to write that down here, is x minus 2 and x squared minus 1. Now x squared minus 1, that's a perfect difference of squares. And so that's going to factor itself. Hopefully you're seeing that pretty instinctively now, is x minus 1 and x plus 1. And this is still f of x equals. Now my roots are where f of x equals 0, and so my roots are 2, 1, and negative 1. Which one did I drop off here? Oh no, it's a third degree. We've got them all. Okay, so I've got 2, 1, and negative 1. All single roots. It's a odd function, so it's a positive a value. So it starts from negative infinity, ends at positive infinity. It's going to be heading on up. It's got a turn to come back through, turn again to head back up, and head towards positive infinity. All right, hope that helped.